I'm Muhammad Usman. I'm a member of Network Security Research Group, School of ICT, and I'm doing research on mobile agent-based anomaly detection in wireless sensor networks. For example, one application area is smart home sensor networks, where sensors are deployed to sense the environment for temperature, for light, and for other measurements, and then that data is transferred to the central node, which is usually a mobile phone, and then user can take appropriate decisions like switching off extra lights and controlling the temperature of the home. So within this kind of setup, those sensors are vulnerable to attacks and faults. The data which is received by the user can be anomalous. So usually what anomalies mean is that when we have a predefined normal behavior of those sensor nodes. So if the received data deviate from those predefined bounds, so we consider it as anomaly. In order to effectively mitigate those anomalies, we need to identify the source of anomalies. My work is specifically focused on identification of the source of anomalies by transmitting mobile agent and investigating whether the anomalies have occurred in situ or in transit. So another advantage of my approach is that conventionally we need to physically inspect the malicious or faulty sensor nodes in order to identify where is the problem. But through my approach, we can transmit mobile agent remotely or without physically interfering the privacy of the residents of the home, which I believe is a good contribution. Yeah, as I mentioned, there are many application areas. Even if you take the example of transport infrastructure, so we can work with the TransLink and some other transport related industries to see whether their networks are risk free. So this is one example. Then there are some other industries. The prime example is power distribution infrastructure, which is controlled by ICT. We can also collaborate with them to identify vulnerabilities if there are any in their network, and to move towards a more safe and secure infrastructure.